Okay, this is note 6.1 part 2. Let's go ahead and start by reviewing electronegativity, and what that is how much an atom wants an electron from another atom. How much an atom on a scale of 0, which is not at all, to 4. So 0 is not at all, and 4 is it really wants one. Okay, 4 is high. Oops. 0 is not at all. Not at all to high electronegativity. So now look over here, we can see the most electronegative is fluorine. Most electronegative. Okay, the most electronegative atom is fluorine. Okay, so then what that tells us is that there's an imbalance here. Some of these things really want electrons where others don't. And how that plays into our bonding, our understanding of bonding, is that whenever you have a covalent bond, some of these things are off balance. So for example, like that hydrogen and fluorine example I told you, see hydrogen's got a 2 for its electronegativity, and fluorine's got a 4. So that means most of the time, or a lot of the time, that covalent bond is actually hovering around, or that electron is hovering around fluorine. So that bond's it's a little off balance, isn't it? So here's how. So let's look at this first of all. Nonmetals tend to have lower electronegativity. I'm sorry, metals rather. I said nonmetals. Metals have lower electronegativity, and nonmetals have higher. There's also strong nonmetals, which are nitrogen, oxygen, fluorine, chlorine. And that's it. These are the highest. These have the highest. These have the highest electronegativity. And then there's the weak nonmetals, which are all the rest. All the rest. Okay? So basically, if you have any of these right here, nitrogen, oxygen, fluorine, chlorine, if they're bonded with something other than themselves, they're probably going to, those bonds are going to be a little bit wonky. In other words, they're going to be off balance. And so that's, how do we apply that? Well, we look at these covalent bonds, and we can further classify covalent bonds into nonpolar covalent or polar covalent. So an example of a nonpolar covalent would be if you took 2 of these strong nonmetals and bonded them together. Sorry, my camera just did something weird there. If you took 2 of these nonmetals and bonded them together, okay, again, if you got 2 of these strong nonmetals and bond them together, you're going to get a nonpolar covalent. So in other words, these two, let's say I took 2 chlorine atoms and bonded them together. Okay, they both have an electronegativity of 3.0. So it's like a tug of war where both of the opponents are equally matched. All right. So in a nonpolar covalent bond, we can say the electrons are shared equally between the 2 atoms. So some examples would be a strong nonmetal, and another strong nonmetal. Or 2 weak nonmetals, right? Okay, so again, what are the strong nonmetals? These guys right there. And what are the weak nonmetals? Everything else, basically. So, for example, if you had carbon bonded to boron, okay, that's going to be a nonpolar covalent. But if you got carbon bonded to fluorine, well, that's going to be polar covalent. Okay, so let's go ahead and do the next one. Well, I just answered that. Polar covalent is when electrons are shared unequally between two atoms. So an example of that would be, well, the example that we did before, which would be hydrogen and fluorine, right? Hydrogen and fluorine. Or hydrogen and chlorine. Hydrogen and chlorine. Mostly it's going to be fluorine and chlorine that are hogging those electrons. Why? Well, look at their electronegativities. 4 and 3 versus 2.1. So most of the time the electron's going to be around fluorine or chlorine, right? And that takes place between a weak nonmetal and a strong nonmetal. Alright, so those are how you can further classify covalent bonds into nonpolar covalent or polar covalent. Well, then you got ionic bonds, which is a complete transfer of electron between a metal and a nonmetal. Okay, complete transfer. An example of that would be lithium fluoride. Lithium fluoride, metal and a nonmetal. And again, examples, or the elements are metal and nonmetal. And we can also say, if you guys recall these vocabulary terms, a cation and an anion. Cation is the metal, it's the positive. Anion is the nonmetal, it's negative. Metallic bond is a sea of electrons, like we discussed. An example of that would be copper and copper. Copper and copper bond. Okay, and that's always just between metal and metal. We don't really discuss that too much in chemistry. We're mostly concerned with these three terms right there. Okay, so in example number 1, classify each of the following bonds as nonpolar covalent, polar covalent, ionic, or metallic, and indicate any charges on the atoms. So the first thing you need to do is classify as covalent or ionic, and then we can go back and say, is it polar covalent or nonpolar covalent? So in this case, Fe and zinc, well, that's actually metallic. Those are both two metals. You'll never see that, by the way. This is just purely for this example here. Calcium and bromine. Calcium is a metal, bromine's a nonmetal, so that's ionic. Hydrogen and chlorine and carbon rather, so that's covalent. So we're going to come back to that one in a second. Sulfur, oxygen is also covalent. Tin and iodine is, well, tin's a metal, iodine's a nonmetal, so that's ionic. Nitrogen and chlorine, both nonmetals, so that's covalent. And phosphorus and fluorine are both nonmetals, so that's also covalent. Okay, that's also covalent. Now, quick little reminder, if you're asking, well, how do you know that these are metals and these are nonmetals? First of all, you shouldn't be, because we covered that already, but a little reminder, if you are, just remember that everything on the right of the staircase here, and hydrogen, and only hydrogen, is a nonmetal. Okay? Everything on the left of the staircase is a metal, except for hydrogen. Hydrogen is a nonmetal. Okay, so let's go back through these then. Let's go back through the covalent bonds and figure out if they're nonpolar covalent or polar covalent. Well, in this case, we've got hydrogen and carbon, and carbon's got an electronegativity of 2.5, hydrogen 2.1, and they're both weak nonmetals, so we're going to go ahead and say this is nonpolar covalent. This is nonpolar. Why? Because you got two weak nonmetals. That's why. Only if you see these in there with a weak, paired up with a weak nonmetal, we're going to call it polar covalent. So nitrogen, oxygen, fluorine, chlorine, if they're paired up with a weak nonmetal, then we can go ahead and call it polar covalent. So let's go ahead and try this next one. We got sulfur and oxygen. That's a weak and a strong, so that's going to be polar covalent. We've got, well, let's see, next covalent bond. It's going to be nitrogen and chlorine. Chlorine and nitrogen, I'm sorry, nitrogen and chlorine both strong, so we're going to say that these are nonpolar because you've got a strong and a strong paired up with each other. Okay, in this case we got phosphorus and fluorine. Well, phosphorus is not one of the strong nonmetals, but fluorine is. So in this case we're going to say it's polar. That concludes part 2 of the notes.